And first up, we have TCP over IP Anycast, Pipe Dream of Reality, and I'd like to welcome to the stage Sean and Ritesh from LinkedIn.
Thanks. Good morning, everyone. Another early session. It can be rough if you had many drinks last night. My name is Sean Zandi with LinkedIn, along with Ritesh. We're here to talk about TCP Anycast and how LinkedIn used TCP Anycast to make the site faster. There has been talks before in NANOG regarding Anycast, and there are so many good resources. Just to quickly overview and define Anycast, when we advertise network objects with multiple nexus, basically we're creating the Anycast. In Anycast word, we advertise the same set of prefixes from multiple locations and rely on the routing information and BGP to distribute the service for us. And it simply works for UDP, obviously for short sessions, and also for TCP, depending on the use case. Next slide is just a simple presentation of advertising the same set of addresses from different locations, from New York, Chicago, and San Francisco, and based on the user location, the shortest path is going to be chosen. So one of the concerns that we had was equal cost multipath with Anycast, and it seems that it's not a real issue in internet today. As long as there's some form of a stickiness for flows, they get the same forwarding treatment. The only time that Anycast can be broken is when we have some sort of pair packet load balancing in transit, which is not very common in the internet these days. On the control plane, it seems that most BGP implementations do not load balance across different AS paths unless it's configured manually. So that's not an issue as well. Complications that we have in Anycast, well, TCP IP stack uses out-of-band signaling for stuff like MTU path discovery, and because it's a different protocol, it may have different forwarding treatment. Therefore, the messages may not reach the intended receiver to report MTU issues or any signaling. The other problem could be RPF. Since you're accessing a prefix through different directions, RPF can be broken. It's a very common practice that to allocate a /24 or /56 in case of IPv6 to a service, so that if the service is not working, you can easily withdraw that is /24 or 56. But while if you're sharing these to or multiple VIPs or addresses under the same covering prefix, then we may have some challenges. And last not least, monitoring of Anycast requires a distributed, comprehensive monitoring system to make sure that everything is reachable from different points of view. So with that, I'd like to pass it over to Ritesh to talk about measurement.
Hello. All right. Thanks, Sean. So hi, guys. I'm Ritesh. I'm not a network engineer or network operations guy. I'm an application developer who's doing performance work. So I might use some terminologies and terms that are different, but hopefully you'll get the message across. So let's talk about how LinkedIn figured out whether Anycast works for us or not, right? Before we go into details, let me talk about what is RUM. That's the technique we use to measure Anycast effectiveness. RUM stands for Real User Monitoring, and it's nothing more than some client code that measures performance. Specifically on browsers, we write JavaScript code because all the modern browsers support RUM off the shelf. We can just write a basic JavaScript and get a lot of data. And what kind of data you can get you can get data about how much time, when you load a page, what was the DNS time, DNS lookup time, what was the connection time, which includes TCP, SSL handshake, first byte time, download time, onload time, and things like that. And you can also do interesting things like you can monitor your performance across the globe and have pretty graphs like that. Now, let's do one more thing. Let's talk about POPs, because we'll be using that going forward a lot. POPs, point of presence, at least to me, the way I think of them are like small-scale data centers. You guys probably know better. But in LinkedIn, we use POPs as reverse proxies. We use them as edges. We use Apache traffic server, and all the client connections are terminated at our POPs. The TCP connection, SSL handshake, SSL connections are terminated at the POPs, and the POPs then talk back to our data center to fetch the data that the client requested. So let's figure out why POPs are important. Imagine a world without POPs. A client in India talking to a LinkedIn data center first will establish a TCP connection. And it might take anywhere, let's say, assume the RTT is 250 milliseconds. So connection will be 250 milliseconds. And then the client will send an HTTP GET request to the data center, right? Assuming server on our side takes around 500 milliseconds, when the server responds back with all the data, because of the way TCP works, because of the congestion control algorithms built in within TCP, depending on the size of the payload we send back to the client, for LinkedIn, it could be anywhere between 60 KB to 100 KB kilobyte pages. It could take anywhere between 3 to 5 round trips to send this data back to the client. Again, because of the congestion control algorithms, the congestion control of TCP allows only 10 segments to be sent in one round trip, and it increases after that, right? So if you calculate all this, how much time it takes for this toy example, for LinkedIn to serve its page to its user, 250 milliseconds plus 500 milliseconds plus around 5 round trips to send the page back, around 2,000 milliseconds or 2 seconds is what the client will wait to actually receive all of the data back. Now let's introduce POPs in between the client and the data center. Assume we install a POP, the edge server around 100 milliseconds from the client, and still the client and the data center are still 250 milliseconds. So right away, connection time reduces because we are terminating TCP at the POP now to 100 milliseconds only for connection. And then when the client sends the HTTP GET request, the POP will forward that GET request to a data center. And it will use an existing TCP connection between the POP and data center because they are talking all the time, so they have keep alives, they have existing connections, so an old TCP connection will be used to send that GET request back to the data center, right? And here's the magic. Because the POP and data center are talking to each other all the time, their congestion control windows are huge. And 60 kilobyte, 100 kilobyte, even an MB of data can be sent across from the data center to the POP in one go, right? Only one round trip. So we don't pay the penalty of having 5 round trips between the POP and the data center because of the keep alive, because we are reusing old TCP connections. Of course, when the POP sends the data back to the client, it still has to go through its 3 to 5 round trips because that TCP connection is new, but that penalty is much lower now. Instead of 250 milliseconds into 5, we are doing 100 milliseconds into 5, right? So if you add all this up, again, 100 milliseconds plus 500 plus 500, now you're only doing 1,100 milliseconds, 1.1 second, right? And right away, basically adding a POP in between, at least for a content provider like us, gives us 900 millisecond gain right away because of the way, again, the way TCP works. So POPs are great. POPs are awesome for improving client-side performance. We should definitely use it. So we started looking into it. And the next question, obviously, is how are users assigned to POP? We know POPs work, but how do we make sure the best user is assigned to the, users are assigned to the best POP, right? So first of all, the mechanism of POP assignment, at least initially, we were doing through DNS, GSLB. IP of the POP was handed to the user based on the user's resolver. So let's say if I do this dig command 2 years back, if I did this dig command 2 years back, in California, I would get a West Coast POP address. But if I do the same dig command in Spain, I'll get another IP address. That's our POP in Europe. That's how users were assigned to POPs. But obviously, the main question is, how do we assure optimal POP assignment? How do we make sure clients closest to the POPs are assigned to the closest POP, right? Like, the basic question is, given a country like India, let's say we have two choices for India, Singapore POP or Dublin POP. Which one should India users get connected to? So to solve this question, we used data-driven methodology, where we added beacons in our RUM monitoring. Again, RUM was a JavaScript client code where this JavaScript is run every time a user loads LinkedIn.com. So what we did was, for a small subset of our users, we have this JavaScript code where for all the POPs that we have across the world, we fetch a tiny object, which is basically popname.perf.link.com/popadmin, and we calculate how much time it takes to download that object. And we do it for all the POPs. And this is done for a random subset of users, for a small subset of users. So this gives us a data about, for a particular user, how much time it takes to download objects from 10 different POPs, for example. And that will tell us which is the closest POP, right? So we send this data all the way back to the servers. And now we can analyze this data to find the optimal POP per country. We can answer questions like whether India should connect to Singapore or Dublin, because we have data from all the users, a lot of users in India, millions of users in India, and we can calculate interesting statistics like what is the time to download that object from our Singapore POP versus what is the time to download that object from our Dublin POP, what is the median time, what is the average time, what is the 90th percentile time, and that way we can identify what is the optimal POP. So that helps us now give interesting performance benefits. Let's say we build a new POP. Let's say we build a Hong Kong POP. This is actual data that we saw, that China, the whole country, users in China, when they connect to our Hong Kong POP, when they download that object from a Hong Kong POP versus Dublin or Singapore, Hong Kong was 434 milliseconds versus Dublin or Singapore, which were much higher. And this download time actually includes TCP connect time, SSL handshake, and the actual HTTP GET. So that's why the numbers are much higher than I expected it to be, but assume it's like around 3 to 5 round trips, right? Similarly, for India, we had the same question, and it turns out Singapore POP for us was better than Hong Kong POP. So we can use that to assign countries whenever we build a new POP. We can also audit our current assignments. This was an interesting finding for us. For me, that was a very interesting finding that India and Pakistan, two countries which are side by side, end up preferring different POPs. We assigned Pakistan to Singapore because we assume, India prefers Singapore, so Pakistan is a neighboring country. Singapore must be better for Pakistan, but it turns out for Pakistan as a country, Dublin POP was the more optimal POP. And that way, we actually fixed the POP assignment and help improve performance. And this is a graph about when we did this optimal POP assignment, what was the download time improvement for different countries. Here, basically, on the y-axis, I have percentage improvement for the LinkedIn homepage download time. And I could see that India improved by around 28%, and median 90 percentile at around 25%. Pakistan, Singapore, Russia, Brazil, and a lot of different countries had improvement. So this made me happy. I'm like, yes, I solved my problem. I'm a performance engineer. I solved LinkedIn performance. But when I look back, I found that there are a lot of problems. I tried to do what we call trust but verify, right? And the problem I found was when we assigned a country to the optimal POP, the assignment was far from optimal. The resulting assignment was far from optimal. Specifically in US, when we did the optimal POP assignment, we found that even after doing the right assignment, 31% of the traffic was still going to the wrong POP. More specifically, almost 45% of the East Coast traffic was connecting to our West Coast POP. while there is an East Coast POP available, and we actually configured our DNS for those users to connect to the East Coast POP. Globally, this suboptimal assignment was around 10%. Right. So what was the problem? When we dug deeper, there were basically two issues we found. One is a user in New York, if they are using a DNS resolver which is all the way in California, that will result in bad assignment because DNS resolution is based on the resolver IP, not the client IP. So a New York user would get assigned to the West Coast POP versus the East Coast POP. And the other one is bad databases, because our DNS providers, how do they map users to data geography? That's just by using some IP to geo databases. So it can happen that even if the user is using a resolver in New York, if the database says that resolver is in California, they will get assigned to the West Coast POP. So let's recap. So we've started building POPs. We found that POPs are very helpful in improving performance. And we used client-side code to assign users to the optimal POP. But we found that there is a lot of suboptimal assignment even after we did the right assignment. Basically, DNS has inherent problems. DNS-based assignment has inherent problems. So how do we solve this? We could bug our DNS providers, and we did that. And after bugging our DNS providers, they upgraded their geo IP databases, and it helped improve suboptimal assignment a little bit, from 31% to 27%. We could start running our own DNS. That could be done, and that might resolve this, because if you run your own DNS, you could build better databases, you could do interesting things, and actually assign clients to the right POP. But how about trying something that already exists, trying Anycast, right? And that was the question we tried to answer. I think you guys all know what Anycast is, but I'll just quickly recap. Given three POPs, A, B, C, with the same IP, 1.1.1.1, a user would go to the POP A in this case because it's only 2 hops away, versus POP B and POP C, which are 3 hops away, right? And since there's no resolver IP here, client IP is used for Anycast assignment or Anycast routing, that problem is resolved. User can use whatever resolver IP they need, they want, but we'll still have the right assignment. And there's no geo IP database involved. Again, BGP does this for us. There's no lookup, so bad geo IP databases don't impact us. The question, obviously, was, yes, Anycast is a promising technology, but will it actually help us? Will it actually send more users to the optimal POP versus using a DNS GSLB approach? So we said, OK, let's do some data-driven tests, experiments, and figure out if that works. And here's, again, how we use RUM, the JavaScript code or the client-side code, to help make that decision for us. We did something similar like we did earlier. We set up a domain, anycastac.perf.link.com, to point to one IP. And the same IP was announced by all our POPs. So that's the Anycast IP for us for the experiment. And then in RUM, again, all our subset of our users would download this tiny object from ac.perf.link.com. And they will read a response header called XLI POP. So what our POPs do is, when they serve this object, they insert a response header, XLI POP, which has the value of the name of the POP. So XLI header, XLI POP, if you read the value of it, it will tell us which POP it was it served from. And again, we collect all this data and send it back to LinkedIn to analyze. So we ran this for a subset of our users for a long time, and now we have information about, for a given user, the right Anycast POP, the Anycast POP that this user would end up going to, because ac.perf.link.com is served on Anycast. And obviously, from our earlier experiment, we have, for a given user, what is the most optimal POP. Again, because we had this object that we fetched from every POP and figured out what is the fastest POP for a user. So using that data, now we can do interesting analysis. We found that some example regions or states in US where DNS was not performing as well. The percentage of DNS optimal assignment was not that good, improved using Anycast. For example, Illinois, right here, used to have only 70% optimal POP assignment using DNS. But with Anycast, it ended up being 90%. Right? Similarly, Florida, Georgia, Pennsylvania. So that's definitely good news. But we also found bad results. We found that Arizona, New York got worse with Anycast. The optimal POP assignment dropped from 60% to 40% in Arizona, New York from 77 to 74%. And Brazil, the whole country, it used to have awesome optimal assignment, 88%, it dropped to 33% using Anycast. So one more animation that expresses my feelings after I learned that. That was one of those days that I thought, damn it, like nothing is working for me. What is happening, right? So then we dug deeper, and specifically the Brazil example gave us the right idea that Anycast does routing based on number of hops. But that does not mean it will always give you routing based on latency, right? Fewer hops is not equal to lower latency. So you could have cases like this where POP X, only one hop, POP X is only 2 hops away from the user, but one of the hops is actually an intercontinental link. And Anycast would prefer that because that's less number of hops versus Z and Y. But Z and Y are in the same continent as the user, and they might be better for latency. Right? And furthermore, I think we learned that carriers prefer to haul packets within their own network. They have policies around that. And if you do peering, that can cause intercontinental shortcuts like this. So how do we resolve this? Well, we came back to think that, hey, maybe DNS wasn't so bad. What we learned was that continent-level assignments for DNS were actually pretty good. It's only at the state or city level that DNS was not doing that well. What I mean by that is if a user is in Asia, you would probably get the Asia POP if you use DNS. They'll not send you to US, for example. If the user is in US, they'll end up sending you to one of the US POPs. They'll not send it to Asia or Europe, for example. So their continent-level GeoIP databases were good. The using resolver IP, everything was better. But they only suffered at a city-state level. So that gave us the idea that maybe we could have a regional Anycast solution where we're using DNS and Anycast in conjunction. And we have one Anycast IP per continent. So again, it's not a global Anycast, it's a regional Anycast. So we'll have one Anycast IP for Americas, one Anycast IP for Asia, one Anycast IP for Europe, and so on. And that way, in this case, in this example, X, which is again a POP in a different continent, will get a different IP, 2.2.2.2, when users resolve LinkedIn.com. But Z and Y, which are in the same continent as the user, would get 1.1.1.1. And in this case, the user would end up going to Z because that's only 3 hops away. And it will not go to X because the user will not see that IP. So we ran an experiment, again, similar experiment as before, where we had RUM download an object on ac.perf.com instead of ACV. We did ACPC, Anycast per continent.perf.com, and we found good results. Everything was fine. Like we didn't see the bad results that we saw earlier. And this is the happy graph work of all this result of all this work. Y-axis is the percentage of traffic going to the optimal POP. And x-axis is our timeline. And different lines here denote different states in US. And we did a slow ramp where initially we did only a few percentage of traffic on Anycast and slowly ramped it going forward, right? So as you can see, as the ramp proceeded, the percentage of optimal POP assignment started improving. For really bad cases like Louisiana, which is the lower green line here, West Virginia, which is a lower pinkish red line here, that had around 50 to 60% POP assignment. They slowly started improving to 80 to 90%, right? For the good ones, like New Jersey, New York, which are already in the 80s and 90s, they also improved to higher 90s going forward as we ramp further. So we have finally ramped US completely on Anycast right now. We have multiple POPs in US, which are announcing the same IP. And right now, LinkedIn.com, www.linkedin.com is served on Anycast in US. You could, whenever you go to LinkedIn.com, the IP you're getting is from Anycast. And ramp outside US in progress. I think we already ramped Europe on a different regional Anycast already. And we are still in the process of looking at Asia and South America. So that's basically it. Let's recap what we did. We started building POPs. We thought POPs were useful for improving performance of our users. So we used client-side code, RUM, JavaScript code to figure out what is the best POP for each user. And we used the RUM to assign users to the optimal POP. Then we found that DNS-based POP assignment is suboptimal. And we evaluated Anycast as a solution using, again, client-side code, RUM. And now we are using Anycast to assign users to our POPs. And obviously, the next obvious play for us is we keep building more POPs, and we keep evaluating Anycast. To recap, I think one of the main learnings I have for this work is that we can use our clients as measurement agents. We don't need to rely on synthetic monitoring only. We can use JavaScript, RUM, client-based measurement to actually do interesting measurements, right? If you have millions of users, use them as your measurement agents. Also, always trust but verify. You think you are doing interesting things. You think you're doing the right thing, but always go back and check your numbers. Always go back if what you expected the result to be, is that the result you're getting? For us, we did optimal POP assignment in US, but we found that 31% of our users were not being assigned correctly. So that led to us evaluating Anycast as a potential solution. Finally, I think, as I said, I'm not a network engineer, not network operations guy, but we collaborate heavily with, I collaborate heavily with the network operations team in LinkedIn. So I think that was one of the learnings, that you can have a bigger impact if you collaborate across orgs. Reach out to your performance team, reach out to your application developers, figure out what their problems have, and maybe you have a solution for them. For next play for us is, next steps for us is we will keep evaluating Anycast. Specifically, right now we haven't done it in Asia, so we'll keep looking at Anycast as a solution for Asia. And we'll keep building new POPs. And that's basically it. Thank you.
Matt Petak, Yahoo. So the talk was about TCP Anycast, and early on you were talking about some of the potential concerns. Did you actually map your data for user connections before moving to TCP Anycast and after TCP Anycast to verify your hypothesis that ECMP wouldn't be a problem, that unstable paths or differing path lengths wouldn't be a problem? Did you actually look to see if you were seeing server-side resets at a higher rate than before to see if TCP Anycast was potentially, while giving better latency assignments, potentially making for a poorer user experience? Yeah,
that's a good point. So I should have added a slide about that. The details are, little more details are on our blog. So we have a blog with the same title on LinkedIn Engineering blog. The answer to your question is, so we did that evaluation. Before we moved LinkedIn.com to TCP Anycast, we ran some synthetic experiments, catch point experiments, where we were downloading big, I think 100 KB objects across from our POPs using catch point. And we tried to see whether there were errors, failures on those downloads, and on our server side, whether there were increased number of TCP resets, for example. And we didn't find any of those we didn't have high failure rate. The failure rate was the same whether you're using Anycast or not, and the TCP reset rate was the same before using Anycast versus after. And then when we ramped, obviously we were careful. We were careful not to do that again. I'll forget it. So yeah, when we ran, we were also monitoring TCP resets on our server side, and we didn't see any increase in TCP resets. But I think that's a valid point to be aware of when you're doing this. And I think Asia is where we are a little bit more careful. so that's why we haven't ramped to Asia yet. We are being more careful. We'll evaluate and go forward.
I'll be looking forward to a blog update after you do Asia. Thank you.
Right, thanks.
Hi, Chris Woodfield, Twitter. Just to clarify, did you deploy any ECMP-based Anycast inside the POP, or were you deploying a single endpoint per Anycast POP?
Sean, would you know?
We do ECMP inside POPs as well, but with different scope.
Okay.
The way that we're using a open source project called IPVS with Apache traffic server, so all of the servers or reals are advertising same BGP address inside the POP and inside the data center. However, we catch that address at the edge and advertise it as a /24 or /56 to the rest of the world. So there are two scopes of Anycast, one regional Anycast and one inside the data center.
Yeah, global Anycast and local Anycast. Got it. Okay, thank you.
Okay. Vikas from Microsoft. So basically, we do the same thing for Bain. It's more like a discussion for Matt's point as well. I think, so what you are presenting is getting the traffic to the site and not to the end server, right? This is load balancing till the site so that the user gets the closest user experience from a nearest POP location, correct?
Yeah.
Okay. Now, so for the DNS, still getting the Anycast IP to resolve to that location in that area, you are still relying on the geolocation mappings of the providers, right?
Yes.
Okay. So did you face problems in China?
Actually, so again, as I said, we haven't done it in Asia yet. We haven't done Anycast in Asia yet. And we are evaluating that. Do you have any experience in China with this severe problem?
Very bad. So,
okay.
Okay. Because everything
let's talk offline.
Sure.
I would like to learn from you.
We can discuss more in detail about this. The second point is, I think, so the inside data center is based on how your load balancing algorithm is to the server. So you would be probably on the point, on the edge. You are monitoring the performance of each server and then taking it out of production in case if there are errors to that server, right? That's how you are doing the last mile server reachability? Or you're doing it in some other way, which is what I'm interested to know. So like this presentation is getting the traffic to the POP, but inside the POP, how are you doing what is the math inside the POP? That's what I'm interested in knowing.
So you're saying once the request comes to the POP,
Yep.
What happens after that?
Yeah.
So the request would get to one box, one ATS machine.
Okay.
And that ATS machine would go and talk to our data center.
Yeah. Okay.
So we have like n number of ATS machines in a POP, and that request would actually end up at one ATS machine.
Yes, but the Anycast still you have 1111, but that ATS would have a private IP, or every machine has 1111 on it.
Okay, that's a good question. Do you know?
That's
Sean? Like within a POP, we have n number of machines. Do they have n number of IPs, private IPs?
Sure, yes. Yeah,
because that's where the load balancing will happen in the POP, right? So you must be measuring that server reliability inside the POP, correct?
Yes.
Okay. Right. We'll talk again. I think I got my point. How you doing?
Okay, thanks.
Hi, Roland Frosek, SurfNet. For improving your DNS experience, did you look at using eDNS client subnet?
Yeah, so eDNS client subnet is a good solution. And 2 years back, when we started this project, most of the DNS providers we were using did not support it, unfortunately. I know one of the DNS providers we are using now supports eDNS client subnet, but obviously the other problem is it needs support from the resolvers themselves, right? And as far as I know, the resolver support is not there yet to have better assignment. Maybe it's improving, I don't know. But
Depends, Google supports it.
I'm sorry?
Google automatically supports it on their public DNS service.
Right, but like most of the world is not using Google DNS.
Look at the presentation from Jeff Houston. A significant proportion in many countries use Google public DNS resolvers.
Absolutely, and actually for Google and OpenDNS and these DNS providers or DNS resolvers, we definitely need eDNS because otherwise you don't know what's going on, right? So yes, we are using eDNS client subnet whenever DNS providers support it, and if the DNS resolvers use it, support it. But I think that still doesn't completely solve the picture, and that's why we needed something like Anycast.
Okay, thank you.
Sure.
Sandeep with Microsoft here. So a couple of questions. So how do you manage the load protection on your POPs? Basically, you were saying that you are having DNS resolution, basically the DNS servers on the POPs, and also the TCP connections for that particular website or the web is going through your POP. So what happens if your POP is overloaded with requests, and how do you manage that? Do you redirect it to somewhere? Do you use DNS redirection, or you do move it to some other layer?
Yeah, that's a great question. In fact, I was just editing my slides to add that Anycast has problems. And that could be one of the problems, that load balancing is not easy with Anycast. With DNS, load balancing is very easy. You could just remove the DNS entry or have weights around it and do that, right? With the Anycast, I think it's a little bit harder, and Sean, you might have more comment, like how do we do it?
Yeah, absolutely. It's a stateless mechanism, so you don't have much control over the load. You just throw more boxes at it.
Or we retract the announcement when we see problems on the POP. But yeah, there's no fine-grained load balancing there. That's
so
definitely one of the problems.
Boxes, like if the POP is overloaded and it's like denying the request or discarding those, so that's impact, right? So how do you don't have any mechanism to overcome that?
Yeah, so what we can do is we can either retract the announcement or right, and then just get like basically that POP is out of rotation in that case.
Or you use some BGP attributes to lower the load.
Mm-hmm. So you have both DNS servers and the servers that handle the first HTTP connections, not HTTP, basically the TCP connection at the same location?
So we don't, right now we don't run our own DNS. We use third-party DNS providers. So we don't have any DNS servers in our POPs.
Okay. And what about the DDoS mitigations in case of Anycast? So is there anything you guys do for that?
So I think for DDoS, actually Anycast is better in a way because Anycast will distribute your load across the world, every POP which is announcing that IP instead of they being able to attack one particular POP.
Yeah, it will be distributed, and I think it won't impact as it would impact a single thing, but
exactly.
Yeah. So I was just wondering if you guys have any use cases or something like that.
No, yeah, definitely. That's one of the one of the benefits of using Anycast is the DDoS protection it offers, and that was anyways like that was one of the reasons we did Anycast also. Like we didn't talk about in this slide deck because this is focused on performance. But yes, that is another definitely benefits of Anycast.
All right. And how about the mobile? You talked about the ISP, traffic coming from the ISPs or the customers, but what about the mobile customers at some remote locations? Or was there any difference in the measurement when you switched over to the Anycast?
Yeah, that's a good question. So mobile, the way we think of mobile, at least right now, is mobile users, mobile ISPs, mobile networks, they end up going to a gateway, right? Yeah. And that gateway is basically the IP that the rest of the world sees. And I think as long as we are able to optimally assign that gateway, I think we are good. We don't have measurements that prove whether we did better on mobile or not. But we have we don't have measurements about percentage of optimal assignment for mobile. But we do measurements of mobile performance in general. And when we moved to Anycast, we didn't see any degradation in mobile performance for our users.
All right. Thanks.
Good, thank you. No more questions? Okay. Thank you.